Now we're going to look at another application for proportions, and this is used in geometry and with similar figures. So the first problem here is similar triangles have the same shape. So they have the same shape, but one may be smaller than the other, or the other one's larger than the other, but their shape is the same. The lengths of corresponding sides of similar triangles have the same ratio. And that doesn't only apply to triangles, it actually applies to any shape. So if we know that they're similar and they're the same shape, then their corresponding sides are proportional, which means we'll be able to set up a proportion to find missing lengths. So for this example with the triangles, there's some terminology here, and that looks kind of scary to begin with, but all that's saying is that triangle FGH, which is our smaller triangle, is similar to that little wavy line in between, represents similar to, that's the symbol, the geometric symbol for similar, to triangle QRS. Find RQ and RS. So we'll find RQ first. Now RQ is going to be from R to Q. Okay, that is RQ. RS is going to be this long kind of slanted side. That's RS. So we have to find both of them. So we're going to start off by finding RQ. That's, neither one's necessarily easier than the other one. So the way we're going to do this is I always like to start off with my missing piece. So we're going to find RQ first. And again, we're going to set up proportions to solve these. So RQ is going to be my X. So in the smaller triangle, what corresponds to RQ? Well, the vertical piece of the smaller triangle is 3. Now we need to pick two other pieces that we know. So it looks like I know QS of my big triangle, or I know the bottom part. So remember, our X comes from our larger triangle, so we need another value from the larger triangle, which is 21, to also go on the top. So the X and the 21 are both coming from the larger triangle. And what corresponds to the 21 in the smaller triangle? Well, that would be 7. So now we just have to solve this. So we're going to have 3 times 21, which is 63, equals 7x. We have to solve our little mini equation, so divide both sides by 7, and that's going to leave me a value of x equals 9. So that is RQ. So I have found half my answer. Now we need to find RS. We found RQ, now we need to find RS. So again, I'm going to have a proportion, so fraction equal fraction. Now I'm going to give RS a different variable. I'm going to call that, we'll say Y. So again, I like to start with the piece that I'm trying to find. So Y is the slanted side of my larger triangle. That corresponds to 7.6 in my smaller triangle. I'm going to use the 21 again, which is the bottom part. And we already know that that corresponds to 7. So cross products, so 21 times 7.6, now that I do not know. 159.6 is going to equal 7y. So I'm going to have to divide both sides by 7. And when I divide both sides by 7, I know it's hard to see, I kind of ran out of room there, but 159.6 divided by 7 is 22.8. So y equals 22.8, that is RS. So there's my two missing pieces. The vertical piece of the large triangle is 9, and the slanted side of the larger triangle ends up being 22.8. And again, you can set up proportions and do this for any shapes as long as they're similar. It doesn't matter if they're rectangles, squares, hexagons, octagons, triangles, whatever the shape may be, as long as they're similar, setting up proportions will work to solve missing parts.